For over 4 billion years, Earth has had a single, constant companion in the night sky. It sits out there, isolated and totally predictable. Imagine walking outside tonight, looking up, and seeing a second massive sphere as it slowly appears right beside it. Your first reaction would probably be to grab your phone. The night sky would be instantly dominated by two giant worlds. Astronomers would drop everything to track this new arrival, and every telescope on Earth would point in the exact same direction. But the awe wouldn't last. A celestial body of that size brings enormous mass and gravity to our immediate neighborhood. This new addition to our sky brings a sudden, massive, competing physical force that directly threatens the delicate equilibrium keeping our planet stable. The first warning signs would be visual. A second moon means a second massive mirror reflecting sunlight back at Earth after the sun goes down. This diagram shows how the sun's rays hit both bodies based on their different orbital speeds. You'd have two entirely distinct lunar phases happening at the exact same time, projecting overlapping light sources onto the surface. Depending on their alignment, you could easily have nights where both moons are full, or positioned perfectly opposite each other. The combined glow would wipe out the stars and eliminate true darkness. Nighttime would become a rarity. Every nocturnal predator that relies on darkness to hunt, and every human sleep cycle tuned to a 24-hour circadian rhythm would face immediate, severe disruption. But the extra light is nothing compared to the extra gravity. Our current moon pulls on the oceans, creating the predictable high and low tides we track every day. Introduce a second gravitational anchor, and the oceans are suddenly caught in a tug-of-war. Here you can see the ocean layer bulging outward in two competing directions. Instead of a simple, uniform ebb and flow, the water is stretched across intersecting planes as the two distinct moons pass overhead. If those two bulges happen to align, the high tides would combine into massive surges of water flooding inland. If they pull at right angles, high and low tides would cancel each other out, leaving coastlines with stagnant, unpredictable water levels. Earth's oceans would transform from a stable, rhythmic system into a chaotic, highly destructive force continuously battering global coastlines. While Earth feels the strain of two satellites, the moons also exert a massive gravitational pull on each other. This orbital map visualizes the constant tension between the two moons. Keeping them from colliding requires exact speeds and perfectly calculated distances. If poorly positioned, their mutual gravitational attraction will slowly warp their neat circular paths into overlapping, unstable ellipses. Eventually, those intersecting paths resolve in one of two ways. Either the lighter moon gets violently ejected out of Earth's orbit entirely, or the two bodies crash directly into each other, raining massive debris down on Earth. Surviving a multi-moon system relies entirely on a high-stakes physics simulation, where a single slight miscalculation in mass or distance destroys the planet below. Let's assume the orbital math works out perfectly and Earth survives. We then have to figure out how to live under a totally different sky. Early human societies built their entire understanding of time, agriculture, and seasons around one 29-day lunar cycle. With two overlapping cycles, tracking months and years would require incredibly complex mathematics from the very start. Looking at these sequential eclipse phases shows just how intricate celestial events are with one moon. With two, astronomers would have to track the progression of double lunar eclipses and predict moments when the shadow of one moon falls directly onto the surface of the other. Imagine having two different lunar phases, two sets of eclipses, and spectacular double moon events. The night sky could become one of the most amazing sights humans had ever seen. A second satellite dictates an entirely different timeline for human history, science, and global culture. In reality, Earth only has the one large moon, and a second one isn't going to spontaneously materialize. Whether such a system works comes entirely down to the precise cosmic variables of mass, distance, and orbital speed. You get the breathtaking, romantic view of twin spheres hanging over the mountains, but it comes packaged with the terrifying risks of shifting oceans and gravitational chaos overhead. Knowing the physics required to keep everything balanced and the apocalyptic consequences if the math fails,
Would you actually want a second moon?